And hello, Data for Democracy. Nick Colley, I'm one of the project leads for Boston Crash Modeling. And today with me, we have Shaker. Hi, Shaker, welcome.
Hey there.
So Shaker has joined us today. He has graciously volunteered to do a Pandas tutorial. This is something that the community has been like, Nick, Pandas, not the cute cuddly creatures, this tool, how do we use it? And we reached out and Shaker graciously said, we can do something. So Shaker, you are professionally a data visualist specialist at ETH University in Zurich. What does that mean?
Right. So I work in one of the core facilities, essentially, at the university, and we offer our services to any of the research groups that are interested. And recently, like for the last about year and a half, I've been doing a lot of work with biologists because, as you may be aware, like in the last 10, 15 years, biology's kind of changed pretty dramatically with the ability to sequence large amounts of data and all these new technologies that have come online that make it possible to generate vast amounts of data. And it's really changed the way that biologists work. And as a result, like they're kind of, really up to their neck in data, and they need ways to understand it and make sense of it. So I work with them to put together visualizations and tools, usually with web-based front ends that allow them to navigate through their data and understand it and try to figure out what kind of questions they want to ask and maybe some of the answers to those questions.
That's awesome. So I take it you use Pandas a lot in your day-to-day navigation.
So yeah, I do. But I should kind of add the caveat. I do use Pandas heavily, but I don't. I use it in kind of maybe in a peripheral way, because for me, it's about getting the data to the scientists to visualize. So I'm not always doing some crazy Panda analysis kind of stuff, but I do use it in order to work with the data and manipulate it and to structure it and get some of the basic answers that I need from the data to pass it on. So I do have experience with Pandas, and I do have a good grasp of the basics, but I'm not by any means a wizard. So like there might be somebody asked some question about some really technical aspect about how some things are implemented in Pandas that I might not be able to answer, but I'm happy to field that and see what I can do. And I should mention that one of the other people on D4D, Yulan Lin, was involved in putting together this tutorial. She very graciously helped, and she couldn't join us today. She's traveling, but maybe she'll be able to participate in the next one.
Yes, and I believe Yulan has also shown interest in offering a more advanced Pandas as well.
Right.
So what is Pandas? We keep talking about it, but for those that don't know, what is it?
Right. So, I mean, it's kind of I guess the simple way to describe it is that it is an implementation of the concept of data frames from R, but in Python. So, and I guess the little bit of context around that, I think, especially with the introduction of NumPy and SciPy, Python has become like a really viable environment for doing statistical analysis and working with data. And I think the kind of leader in those domains, I mean, I guess like MATLAB and R probably have a little bit more historical engagement with those domains, but especially, yeah, like recently, Python's become very viable for doing that sort of work, and it has the advantage that it's a general purpose programming language and environment, so you also have access to a lot of other great things that you sometimes want to make use of, which is also why I ended up going the Pandas route and not, for example, R, because I needed to interface with other systems, databases. I needed to be able to put a web server in front of some of the things I was providing, and so Python is a really good environment for all of that. And Pandas really fills this gap that is there in the ecosystem that needs to be filled, which is making it possible to work with tabular data in a really kind of both not efficient and intuitive, relatively intuitive way. And Pandas is very much inspired by R, in particular the concept of data frames in R, but did like a Python twist on that idea.
Okay, so now DataFrame is it appropriate to consider a data frame just like an Excel table, but something you can access programmatically?
That's basically right. Yeah. That's a good example of it. That's a good description of it. Yeah.
Okay, excellent. For those that are watching along, we have a live chat on the YouTube page, so feel free to add your questions there. We're constantly watching it, so if there's a question that comes up, we will catch it and make sure it gets added to the list. And we've also posted the you posted this tutorial we're going to be following. It's a Jupyter notebook. It's on GitHub. GitHub. There we go. Words out of mouth. We've posted the GitHub link in the chat window, and it's also getting put into the description for this video for those that are following along later.
Okay, cool. Yeah. And I should add that we got started on it, me and Yulan, and it's still kind of a little bit of a work in progress, but we'll be tying up the loose ends kind of as the week continues, and then it should be a little bit more self-contained and comprehensive once we're done with it.
Excellent. And there's also a Pandas channel now in Slack. So if you have questions about how to use Pandas, feel free to go there, and there's a great group of people ready to answer those questions.
Oh, that's cool. I should join that one.
So yeah, all right, well, let's kick this going. And Shaker, you have the stage.
All right, let me maybe share my screen here so that people can follow along. And yeah, if you go to the Git repository, you should see the notebook visualized in the repo, which you can use to follow along. And there's also kind of like a basic README, which should tell you how to get it installed on your local environment if you want to do it that way. Okay, let me start here. Let me just take a look. Okay, yeah, it looks good. All right. So let's start kind of at the very beginning. So in the first cell, there's usually some boilerplate stuff you always need to include when you're working with Pandas. That's Pandas itself, of course. NumPy is very convenient because Pandas builds on NumPy in order to achieve an efficient implementation of the stuff that it offers. And then there's just some kind of plotting stuff that I like to include too, like use matplotlib to generate plots. And I like Seaborn as well, which is a kind of a more a high-level, powerful plotting environment that's built on top of matplotlib. So I'm just going to go ahead and include all that stuff. And there we go.
Seaborn plugs nicely into the IPython.
That's correct.
Jupyter Notebook. Sorry, Jupyter.
That's right. Yeah. So matplotlib, which Seaborn builds on top of, it has good integration with Jupyter, so you can display the plots like inline, basically in your notebook. And we'll see a couple of examples of that later on here in this notebook. So what kind of when you asked if somebody could do this Pandas tutorial, I thought a little bit about like how to approach it. And I looked at a few other tutorials, and I think one of the things that I both realized again when looking around, and I remember from when I was initially learning it, is that a lot of the tutorials out there, they work on these like kind of contrived synthetic data sets. They generate their own data in code, and then do these manipulations on there, which I guess the motivation for that makes sense in that it keeps everything self-contained. You don't have any references to anything outside that people might not be able to access. But on the other hand, it makes the examples like really a little bit contrived and a little bit hard to follow. So I decided to kind of work with a more concrete example. And serendipitously, I'm working through this book right now by Richard McElreath called Statistical Rethinking, which is kind of an introduction to data analysis, but from a Bayesian perspective as opposed to a frequentist perspective, which is probably what many people at least encountered, especially like if they went through school, 10, 15 years ago. And one of the chapters in there, it contains an introduction to our data frames. And I thought, well, hey, this is great. I'll just piggyback on top of this and use it to introduce the Pandas stuff. So that's what I ended up doing. His data is available in his GitHub repository, which is very cool. It was it's kind of interesting data as well, because it's about these people who live in the desert of Africa, in like southern Africa. I believe they're pronounced like the Kung, but I'm not a linguistic expert on on nomadic peoples or anything like that. So I might have that wrong. But in any case, this is data that was collected in the 60s by an anthropologist who was studying this population. And it's kind of a nice data set to play with. So that's also convenient. All right, so moving on. So the first thing you do in Pandas is you usually want to read in some data, at least the way that I want to approach it. And that's kind of my criticism about the other tutorials, because they start with generating data, but you very rarely actually want to do that. You generally have some data that you need to read in. And what I'll do with this tutorial is I'm just going to go maybe through the cells once quickly, probably too fast, but then we'll go back and go through them in greater detail and see what's happening under the covers. So the first thing you do is read some data. There's tools for reading data in CSV format, JSON, a couple of other formats, and there's also ways to configure it and customize it. So here, for example, I'm reading in a CSV file, but the separator is actually not a comma, it's a colon, but that's all no problem. And then once I've read in the data, I get a data frame, which you see visualized here. And the nice thing about Pandas with respect to Jupyter is that it also integrates very well with Jupyter. So it has like nice displays of its internal data structures that make it easy to understand what's inside of them. So it's very similar to an Excel table. You see there's, in this case, 4 columns: height, width, weight, age, and this kind of indicator, male or female, with 1 being male, 0 being female. And then there's a bunch of rows. In this case, the rows are numbered. They're indexed by number. But we'll see some examples where that doesn't have to be the case. OK, so usually when I work with Pandas, after I read the data, I just want to take a look at it. So I'm going to do that quickly, too. So Pandas already has some built-in capabilities to do plotting, which is very helpful for quickly understanding your data. So generate a scatter plot using the plot method, or I guess, yeah, what's it called? Property or something like that of the frame. Gives you an object that allows you to generate a whole bunch of different kinds of plots. And in this case, I've chosen a scatter plot. And I'm plotting the column age in the x-axis against y in the against height in the y-axis. And this is what the data looks like. And as you can see here, not surprisingly, there's a very high correlation between age and height among people who are still growing. And then once people reach adulthood, they stabilize in their height, and you can see that immediately in the data. In McElreath's kind of presentation of the R data frames, the goal behind that is to create a model of height in a population. And I thought that was also a good kind of motivation here. Maybe not so much a model, but just kind of a little bit better understanding about how height is distributed in a population. So since I'm taking over that goal here, I'm also going to do some kind of necessary manipulation in order to get at the data that I want. So the first thing is, if I include children, I'm obviously going to have some weird distortions when trying to understand how adults' height is distributed. So let me get rid of all the children, and let's take a look at the data again. So here you see a scatter plot. This looks much more kind of properly distributed. It's not it doesn't have this weird correlation between height and age that you see in the full data set. You just see kind of essentially no correlation between height and age, which is appropriate for the task that we have. So here's the magic incantation that I use in Pandas in order to filter my full frame down to just the adults. I think it's pretty readable, which is the nice thing about Pandas. It might be a little opaque at first as to how you construct that, which is okay, but if you're familiar with Python, you should probably quickly intuitively understand what's happening here. And the same is true of the R users, I'm assuming, who are familiar with the R data frames. It's very similar to how that works.
Essentially, you're just iterating through, looking at the line that you have highlighted, you're iterating through the data frame for the column age, where anything is greater than 18, and assigning that to the adults data frame.
That's correct. That's correct. Exactly. Right.
Now, is there a difference real fast? Because I noticed you wrapped the DF. So you have data frame, then you have data frame bracket age. Is there a specific reason for looping that in twice?
Yeah, right. Because yeah, we have to kind of unpack the statement here in order to understand what's going on. So the first thing, actually, let's go ahead and do this since you ask. Okay, so let me just grab this. I'm just going to scroll down to the bottom of this, and we'll come back to this cell in a minute. I'm just going to grab this whole thing, and we'll start taking it apart. Cool. All right, so let's take a look at this first statement. Let me just comment that out here. Okay, so it's made up of a few different parts. So let's start with this. And you see me always calling this head statement. That's because it's like 500 rows in the full table. So it just kind of gets a little bit unwieldy to look at that. By calling head, I can reduce it to just the first n. By default 5. I can also call tail to get the last n. So I often do that if I'm just trying to show the structure of the data that I'm looking at, not necessarily the full data. So if you take a look at this, it's one column of the frame. And there's a couple things to note about it. You see, it's not just like a regular Python list or something like that. It's not a regular Python collection data structure. It's rather, you see, it's first got a few of these, like, some extra information on here. It's got a name. It knows that it's the name age, and it's also typed. It knows that it's contains float data. And then you see the index here. In this case, the index is an integer, which represents the row number. But in other cases, it might not be that way. And so I'm just pointing that out since we're looking at that here. So, okay, obviously, this alone doesn't allow me to select the data I'm looking at. It's just like the column of the data. So I'm going to add the next part of that statement. And this is going to give me another pandas object, so I can call head on it again. Right, so this is another, essentially a column in a table. The pandas name for that is a series. So a data frame is made up of multiple series, and each column is one series. And now I've got a series of Booleans. You see that in the data type as well. And this is what I can use to select the data. I'm just going to, just for the purpose of pedagogy, I'm just going to use a little bit, I'm going to just take a different column. What's it called? I think it's called male, right? Let's take a look at this one. Just so you see, it's not always all true, right? In this case, it's like true, false, false, true, and so on. So the result obviously depends on the content of the column. And then what happens when I put that into the brackets around the data frame, which is kind of like the array access operator in Python. Here you see that array access operator is going to treat it kind of as like a selection and not necessarily like a bunch of indices into the array, but it's going to treat it as if, like, do I want to take this row? So let me just quickly do that. You see some garbage here. What's wrong? Right. There you go. And again, just to make this a little bit clearer, I'm going to do the same with the other selection criteria, just so you can see that it's actually kind of doing something. So here you see it much more clearly because you see that the row numbers are no longer kind of consecutively incrementing numbers, but they kind of jump around a bit because it looks like all of the odd rows contain female information. I hadn't even noticed that. Sorry, all the odd rows contain male information, except for one. All right, maybe it's not true. So you can see that how Pandas is kind of like piggybacked on stuff that's built into Python and uses this array access operator, but done it in a way that's a little bit like clever and sneaky and uses it for a slightly different purpose, but one that kind of makes it possible for someone who's familiar with Python to still understand what's happening, even though it might look a little strange. For someone who comes from R, that probably looks a little bit more natural because R includes this kind of data manipulation as part of the core of the language.
Thank you for that.
Yeah, does that kind of clarify a little bit what's going on there?
It does. Thank you.
Yeah, cool. All right. So then, yeah, and honestly, a lot of the kind of learning curve for pandas for someone who's familiar with Python is getting a feel for this stuff that pandas does that's a little bit different, a little bit not unconventional within the general kind of Python environment. And it takes a little bit of time before you grok all this stuff. And there's a few more examples of these kinds of things where your Python intuition might sometimes lead you a little bit astray because pandas is drawing from this other tradition R, or it's trying to make things as intuitive as possible, but kind of a little bit limited by the way Python works, and trying to square the circle a little bit, and trying to kind of merge these two worlds in a way that it's not all too like incongruous and weird, but at the same time, it's not possible to do it in a way that's always completely in line with your intuition as like a Python programmer. But that's the trade-off there. Okay, so let's just make sure that what I've done in this line here actually has selected some data, and we do that by just comparing the number of rows in the two different frames. So in the original frame, which I call DF, which is short for data frame, I have 544 rows. And in the second data frame I created, the adults data frame, I have 352. So that's good. So it looks like we're on the right track. So I did properly select out a bunch of data, and we can see that both in this kind of quantitative information here and regarding the length of the data frame, and we can also see it kind of graphically here in the scatter plot of the data that I've selected down to just the adults, because you see here there's no data points below like 18 years old. All right, so moving on. Let's now take a look at how data is distributed, how height is distributed among adults. And we're going to do that by taking a look at a histogram. So this is another kind of convenient plotting function that Pandas has built in, the ability to just take a column and generate a histogram of it. So here's the histogram of height, and might be kind of immediately obvious to some people that this is sort of normal, but it's a pretty fat kind of like center of the of that distribution, and again, something it's probably intuitively obvious is that the reason for that is usually like the height is distributed kind of bimodally with like two normal distributions, one representing the female population and one representing the male population. So let's take a look and see if our intuition is correct, and let's go and split the data into male and female and see if we can kind of tease out the normal distributions that we expect to find there. All right, so let me execute this. And what I did here is I added a column, which is the sex column, because I find it a little bit confusing myself to work with these like indicator columns where you have like it's titled male, and like 1 means yes male and 0 means no not male, that means female. So I thought we could go ahead and just make the data a little bit easier to both work with and display by introducing an extra column. This is a common operation that you end up doing with pandas a lot. And there are, once you kind of get the hang of it, there are straightforward ways to do it. One of the slightly counterintuitive things about it is that for reasons of efficiency, Pandas does not store data internally as rows. It actually stores data as columns in order to facilitate the operations that you want it to do and make it possible to do them quickly. So as a result, like just kind of iterating, like if you're coming to pandas from Python, you might want to just do kind of like a for loop and start doing something like, for row in df, and then just start doing some row manipulation. But that's actually not going to work because of the way pandas store things internally. So there are some kind of ways to simulate that, but it's better to actually not even bother with those and just go right to the pandas native way of doing these kinds of manipulations. And one of them is this method apply that's available on both frames and series, which allows you to, it kind of tells pandas, here, I'm going to give you a function, and I want you to execute this function on each column or row. And the way you specify that column or row thing is using this access parameter to the method of apply. So that's what I did here, and I just had go through, iterate all through all the rows and check if the row is the value of the male column in the row is 1, then return male, and if it's not 1, then return female, and assign the result of that operation to the column sex. And since I've altered the original data frame, I'm going to have to refilter to get back to my adults, and then get a version of the frame with the new column that I added there. And I'm going to use that in 1 second here, and I'm going to do that right here. And let me take apart what's going on in these 2 statements that I just executed. So the thing I want to highlight in this line, where I look at the adults and I call this method describe, which is part of pandas, which gives you like a John Tukey kind of 5-number summary of the data, is that I've called it here on a subset of all of the columns, just for purposes of illustration. I can also, of course, call it on the full frame, but then I get, for example, like male as one of the summarized columns. And that's kind of not really very interesting, because it's just this like Boolean indicator field. So I just went ahead and filtered that out. Oops. Just undo that. Right. I just went ahead and filtered that out by explicitly specifying which columns that I wanted to take from the frame. And this is another thing that's kind of typical in R. And this is the pandas version of it, which is a little bit more, maybe a little bit quirky. But again, intuitive to understand how it works, is that you can extract not just one column, as I did here to filter the age, but you can actually extract multiple columns and get a new frame that contains just the columns that you explicitly specified. And that's what I'm doing here to get the description of it, because I'm curious in particular how these various variables are distributed among the population. So if you look at age, it's done alphabetically. You see that like the 50th percentile, the median is 39. The mean's 41, pretty close. Standard deviation is 15. Okay, cool. Then if you look at height, again, you can kind of see the mean again, and the standard deviation, and you see all this other stuff, and the same thing with the weight. And I wanted to compare that to how things look like when it's broken down by sex. So I've got another version of the call here where it's a little bit more snazzy, and I do a couple more things with it. So the first thing I do again is I filter the frame to the columns that I'm interested in, which are again age, height, and weight. But I also added the sex column because I need to use it to group the data. And then I can very sneakily call describe on this group. And Pandas is very sophisticated and can do the right thing when it gets this kind of sequence of calls. And what it does is it actually calls that describe method on each of the subsets where sex is the same, but then merges all of that data together in the final result to produce this big frame, which has kind of the data that I asked for, but it's grouped by sex. So it's pretty cool. So you can now, again, compare, for example, what the median age is among women. It's 38. Median age among men is 41. Okay, so that's pretty close. Median height among women is 149, 150 centimeters, let's say. And among men, it's 160 centimeters. So now you're starting to see that, okay, there's actually a real difference in the data when you look at it by sex. And again, if you look at the weight, you see something similar. Like the median weight is about 41 kilograms, and the median weight for men is 48 kilograms. So those differences that we kind of intuitively expect to see in this kind of data, we do see once we start properly kind of pulling the data apart into the way that we need to in order to find these things. All right. So that's kind of, I wanted to kind of bring back what I said there and just draw really the focus to those things, just to the mean and the standard deviation of the two populations in terms of those three variables that we're looking at: age, height, and weight. So here we've got mean age of the women, 40, mean age of the men, 41, very close. Standard deviation, again, 16 versus 15, pretty close. But height, you see the differences that we expect. The weight, you see the differences that we expect. And here it's kind of presented in a form that's a little bit more focused than above, where you have a lot of additional sort of superfluous information like this count and stuff like that. And what's really different about the way I've gotten to it is how I've accessed the data. So this part is exactly the same as above, where I called the group by and then I called describe. Exactly the same, group by describe. But instead of presenting the full frame, I'm now zooming in on a certain section of it using this lock method, which I guess means location. And well, I'm going to go into greater detail on that later, but I just wanted to kind of give you a taste of it up here. Okay, so now
I appreciate that call out that you'll come back to it, because I had a few questions ready for you.
Yeah. Actually, you know what? If you got questions, let's go ahead. Let's take them right now.
So with the lock, so we're seeing a slice. We see you're doing it by mean and standard, but then we see an empty colon. That's
yeah. This is pretty opaque. This is kind of the weird pandas magic. This is kind of the area where it's really deviates from standard Python land and kind of gets a little bit weirder. So let's go. I'm going to go scroll down to the bottom of this thing and let's start taking this thing apart. Okay, here at the bottom of the notebook, and let's explore this. All right, so let me first execute this statement here. Okay. So what is going on? Let's take a look at the whole frame. Right, so this is the original summary frame that we had above, broken down in by sex and columns representing the various variables that we're looking at. So I said earlier that like sometimes you index the rows in a frame by numerical index, but sometimes you actually need to access it by something else, or you want to be able to access it by something else. So of course, if you if you try to access it by numerical index, you can use this ilock method and grab the 0th row, but and actually let me see here, what can I do? Right.
So ilock goes and grabs just those specific rows you're accessing.
Exactly, by index. But in this case, that's not the most convenient way to index it, because it's given names to those columns, right? It's not just like, whereas above, it's pretty intuitive to say, oh yeah, give me row number 3. Here, you probably don't want to say, I'm interested in row number 2 or whatever that is. You want to say, I want the female mean and the male mean. And Pandas gives you the ability to both describe a frame and describe the rows of the frames in that way, where you say, I want the rows to actually have names, not just be 0, 1, 2, 3, 4, and so on, but I want to give them names sort of similar to the way I give columns names. And I also need tools to be able to access that. And one of the kind of initially confusing things maybe about the Pandas world is how this kind of array access operator has been used and applied and kind of twisted into several different forms. So if I, for example, try to do this, right, this kind of, I can imagine you might think, oh yeah, this would be, give me the mean row of this frame. But it's not going to work because that's not actually how it's accessing things. I can get a particular column that way, but I can't get to the rows that way so easily. So the best way to do it is use this lock method. And the lock is kind of changes the semantics of that array dereference, in that if I specify like the name of something, in this case, so before when I had it applied to the frame, it grabbed a column. But once I start using the lock method, it no longer applies to a column. If I just specify one argument there to the array dereference, it actually refers to the rows. And the other thing is, because that frame has named rows, I can't access them using the lock method by index. I have to access them by name. Let's try this. Right, so now I'm getting kind of closer to where I want to be. So now I can access one of the rows, and I should use kind of air quotes around one there, because in this case, actually not just one row, it's a whole bunch of rows, because this particular frame has like a multi-index. But actually, let me start with the more basic version and do it this way, just so that we don't kind of put the cart before the horse. I'll come back to that one. Okay, so just to kind of simplify the indexing initially, all right, I've now generated a summary of the full data frame, so there's no need to break it down by male and female. And I can now go ahead and access the mean right there. Oh, if I use the lock method. Right, so now I get the mean row as a pandas series. So for that, I have age, height, and weight. And I can also even here, there's two ways to kind of continue dereferencing that. I can say age here in kind of like a two-stage access to get there, or I can use the one-step access, which is the preferable way to do it actually, where I offer, I split up the arguments by a comma and say, the first one represents the row and the second one represents the column. So are you still with me here?
It's getting there. It's getting there. Sorry, I know I threw you off a little bit.
No, that's cool. This is super confusing, honestly. So yeah, this is the mastery of this sort of stuff is kind of what you spend the first, your first experiences with pandas trying to get a handle on. So it's good to kind of cover it here. But I realize it's not something that you immediately grok, because it is sort of a little bit counterintuitive as a Python user. Okay, Let me just do that again. Let's just go through all the different variations for how you access this. So if I just say mean here, I get nothing, right? Because I have to specify a column. But I can say age, and I get the age column of that summary. Similarly, I can use this lock method and specify a row by name here, and get that. And in this case, I get a series now that represents that row. Or I can, if I'm interested in doing it by index, I can use the ilock method and specify an index. And which one is? Oh yeah, there it is. And do it by index. Now, to kind of throw another wrench into that whole works there, there's also multi-indexes, which is what we're looking at in this case. So here, I no longer have just one kind of identifier for each of the rows. It's actually two identifiers, because you can see count appears in multiple places and mean appears in multiple places and so on. So there's kind of this like two-stage way of accessing it. And I mean, you might do this yourself in like Excel too, where you have some kind of data where it makes sense to kind of group things together using like two different like axes to group things together. And then you end up with a similar kind of table in Excel. And this has its own kind of trickiness with respect to accessing. So if I now call lock and say mean, I get nothing, because there is actually no row that's just called mean. There's one that's called female mean, and there's one that's called male mean, and I need to actually specify that. So I can do that this way, and the way you do that kind of stages of dereferencing is by using tuples in Pandas. Now I'm getting to that female mean row, but I had to do it with like this extra kind of stage of indirection there, where I say first give me the female data, and then give you the mean from the female, because that's the only way to uniquely specify that.
And to clarify, I'm noticing a clear difference of when to use parens versus the brackets.
Right.
The brackets, correct me if I'm wrong, is a reference to the data frame, where the parens are a reference to... Oh, sorry, that's me asking.
No, oh, right. So yeah, so right. So if you come from like MATLAB or something like that, the parens you might be expecting to use for array dereferencing, but that's never the case here in Python and in Pandas. The parens are used in order to specify a tuple, which is how certain things get, which is kind of like a multi-step name for something. If that makes any sense. Let me maybe I can.
That's one of those things that's going to come with time, I'm assuming.
Right. I mean, maybe, yeah, you can kind of see it a little bit here. If let me just reference one of the thing by number, right? Because that's unique. I can always say, give me the first row, row number one of that. And you see here, the name is not just mean as it is in this one. If I reference the first row in this other frame, it's just mean. The name is actually this tuple of two different kind of names, female and mean, put together. So it's kind of like in a database where you might have like a composite key.
Okay.
If that's a helpful analogy.
That is. We can come back to that later. I feel like there's probably a whole session we could probably have on just this.
Yeah, it could be. Yeah, it might have been a little bit too ambitious to.
We appreciate it. We appreciate it. Thank you.
Let's just keep going here with taking a look at the data. So getting back to the this example that we're trying to do, which is trying to find the two normal distributions in the height data. One great tool for visualization in Pandas is Seaborn, which is a visualization library, which is kind of, I think it's possible to feed it data just from like NumPy. It doesn't have to be Pandas data, but it's aware of Pandas, and it works very nicely if you give it Pandas data. So you can give it a frame and kind of have it do certain things using that frame, and be able to specify that in a really very intuitive and compressed manner. What I'm doing here is I'm using Seaborn in order to create a plot where the data is split by sex, and just show me the height data kind of together, but broken down by sex in one plot. So Seaborn has this great tool called the facet grid, which allows you to facet data based on different different values. So for here, in this case, I've specified the hue, which is the color, right, to be defined by sex. And the size is just how big I want the plot to be. And then once you do that, you get this like grid object, and then you can use that to generate a whole bunch of different plots. So the first thing I've done is I told Seaborn, I'm going to generate a plot, and I want it to be split. I want to split the color based on the sex, and then it gives you this kind of like this object that allows you to manipulate that, where I just say, all right, I want to plot using the disk plot, which is one of the plots that's built in. That's this plot that's built into Seaborn, and I want to do it on the height variable. And actually go ahead and add a legend too, so that people can understand the data. And using just those 3 lines, you immediately get this kind of really nice plot, which is starting giving you kind of that picture of the data that we intuitively expect, given our understanding of how height is distributed in human populations, and just make it possible to visualize that. So that's what you're seeing here. So you see the female in green, and you've got the distribution, the implicit distribution that it's computed from the data using the histogram, kind of overlaid on that. And then you've got the male population, the male subset of the population, displayed the same way here in blue. And so you see that like bimodal distribution there really vividly, broken down by color. And yeah, the last couple steps here are going to be, let me just run through them quickly to show you what the result is, and then we can.
I mean, we're coming close on end of time, so if it's okay, it might make sense to come back and do lesson 2 on another Monday.
That's fine. Yeah, let's do it that way. But I just wanted to show this plot quickly, just to kind of show you that, like, okay, with a little bit of additional kind of manipulation of the data, I can now suddenly do this thing where I've now taken each one of those variables, height, weight, and age, and put it into its own plot, but put them all together. Kind of, this is technique that I guess like Tufte would call like small multiples, where you have a whole bunch of plots right next to each other that allow you to like see a huge amount of data at once, where you can see the height, which we looked at earlier. You can see that weight is similarly kind of bimodally distributed there, with like men being slightly heavier than women on average. But then you can look at like age, and you see, well, age is pretty flatly distributed. It kind of doesn't matter. Men and women are kind of evenly distributed in the age variable throughout that population. So this is kind of more of just just kind of a teaser to show you kind of like, well, with pandas, you can do some manipulation of the data in order to get these kinds of like plots, in order to pull out the aspects of the data that you want to look at in kind of very concise way, once you've got the pandas commands at your fingertips.
Excellent. For the stuff that's been covered, for those that are watching, if you have any questions, feel free to ask away, and we'll make sure we get them covered. But first and foremost, Shaker, thank you so much for doing this. Just even diving in, I'm sitting there like, oh, so that's what that means. So this has been very valuable.
Okay, yeah, that's great. Yeah. And like I said, I mean, I do realize, especially not only presenting, I realize it's like a ton of material that's being covered here, and a pretty like breakneck pace. So during this week when I get kind of a chance to do things, and I expect Yulan to help me as well, hopefully, we'll fill in the details, and we'll like kind of flesh out this Python notebook here and kind of explain what's happening in all of the steps in a little bit more detail with a little bit more verbiage there, so that the people can maybe grok it themselves, and be able to kind of get the pandas commands underneath their fingertips as well.
Definitely. And we will be announcing the lesson 2 time in a coming announcement. We do have a Hangouts channel now in Slack. So if you have any suggestions for upcoming topics or things, community, please feel free to reach out there. That's also where you'll see the agenda for all upcoming chats or Hangout sessions. Matter of fact, if I can not minimize my Slack, I can show my screen and show what I'm talking about. So, yeah, we've got hackathon prep coming up next Monday. We then have a post-mortem following the 3rd after a long weekend. It's very important that we get feedback from the community about this, because this is our first ever hackathon. We want to make sure that we get your input, and that when we have our next hackathon, that we make them better and we make them work more for you and give you time for you to work on cool projects. And April 10th, we have an upcoming topic that'll be announced shortly. So Shaker, again, thank you so much. Thank you, Yulin, for helping out. We know you couldn't be here, but look forward to having you both on at a future time.
Yeah, great. Yeah, thanks for giving us the opportunity to do this. I think it's hopefully something that the community will benefit from.
So excellent. Well, thank you again, and have a great day. And until next time, community, have a good one.
Cool.
And we're off. So.